Chapter 30, Section 1, Interactive Reader, pages 467 through 472, worth 16 points. Stars, galaxies, and the universe. Characteristics of stars. Key ideas. As you read this section, keep these questions in mind. How do astronomers determine the composition and temperature of a star? How do stars appear to move in the sky? How do astronomers describe the distances to stars? What is the difference between absolute magnitude and apparent magnitude? Page 467. What is a spectrograph? How do scientists use a star spectrum to determine the star's composition? What is a star? Highlight. A star is a ball of very hot gases that emits or gives off light. This light comes from, highlight, nuclear fusion within the star. Nuclear fusion happens when, highlight, a small atomic nuclei combine to form larger atomic nuclei. Most stars in the night sky appear to be tiny dots of white light. In fact, stars vary in color. For example, the star Antares shines with a slightly reddish color. Our own star, the Sun, is a yellow star. How do astronomers learn about stars? Astronomers learn about stars by studying the light that stars emit. Astronomers study starlight with spectrographs. Highlight. Spectrographs are tools that separate light into different colors or wavelengths. Continue highlighting. Light that passes through a spectrograph produces a range of colors and lines called a spectrum. Continue highlighting. A star's spectrum shows the star's composition and temperature. The flowchart below describes how a spectrum indicates a star's composition. Highlight. Elements in a star's outer layer absorb different colors of light emitted by the star. Therefore, the star produces a spectrum that does not contain all the colors of light. Highlight. Astronomers study a star's spectrum to find out which colors of light the star's outer layers absorbed. Continue highlighting. The colors missing from the star's spectrum tell the astronomers what elements are in the star. Question 1, what is a spectrograph? A tool that separates light. A tool that separates light into different colors. Into different colors. Again, a tool that separates light into different colors. How do scientists use a star's spectrum to determine the star's composition? They study the spectrum to determine. They study the spectrum to determine what colors the outer layers absorbed. What colors the outer layers absorbed. Again, they studied the spectrum to determine what colors the outer layers absorbed. Page 468. A star is made mainly of hydrogen and helium. Name one difference between a star's composition and Earth's composition. Name 3 stars that are hotter than our Sun. How can a star that has more mass than our Sun be smaller than our Sun? The composition of stars. Highlight. Each chemical element absorbs and emits certain wavelengths of light. Continue highlighting. The colors and lines in the spectrum of a star show which elements make up the star. Continue highlighting. Spectrum analysis shows that stars do not contain any elements that are not found on Earth. Continue highlighting. The most common element in stars is hydrogen. Continue highlighting. Helium is the second most common element in stars. Stars have small amounts of other elements such as carbon, oxygen, and nitrogen. A star is made mainly of hydrogen and helium. Name one difference between a star's composition and Earth's composition. Question number 3. A star is made mostly of hydrogen and helium. A star is made mostly of hydrogen and helium. The Earth lost most of its hydrogen and helium. The Earth lost most of its hydrogen and helium. Again, a star is made mostly of hydrogen and helium. The Earth lost most of its hydrogen and helium. The temperatures of stars. The color of a star indicates the star's temperature. Most star temperatures range from 2,800 degrees Celsius to 24,000 degrees Celsius. Highlight, blue stars are the hottest. Their average surface temperature is 35,000 degrees Celsius. Continue highlighting, red stars are coolest. Their average surface temperature is 3,000 degrees Celsius. Yellow stars have surface temperatures about 5,500 degrees Celsius. The table below shows the relationship between star color and temperature. At the top of the table, blue are above 30,000 degrees. 10 Lacertae is an example. Blue-white, 10,000 to 30,000 degrees. Regal and Spica are the examples. White are 7,500 to 10,000 degrees. Vega and Sirius are your examples. Yellow to white is 6,000 to 7,500 degrees. Canopus and Procyon are your examples. Yellow, 5,000 to 6,000. Highlight, our sun and Capella are the examples. Orange, 3,500 to 5,000. Arcturus and Aldebaran are the examples. Red, below 3,500. Betelgeuse and Antares are your examples. Question 4, name 3 stars that are hotter than our sun. Pick any 3 stars from Canopus, Procyon, Vega, Sirius, Regal, Spica, and 10 Lacertae. Anything that's above our sun on the chart. Pick any 3. Highlight those 3. The sizes and masses of stars. Highlight, stars vary in size. Continue highlighting. The smallest stars are slightly bigger than Jupiter. These stars are about 1/7 the size of our sun. Highlight, most of the stars you see in the sky are about the size of our sun. The sun is a medium-sized star. It has a diameter of about 1,390,000 kilometers. Highlight, some giant stars have diameters that are 1,000 times the sun's diameter. Highlight, stars also vary in mass. Many stars have about the same mass as the sun. However, some stars have higher or lower masses than the sun. Highlight, very dense stars may have more mass than the sun and still be smaller than the sun. Continue highlighting. Less dense stars may be larger than the sun, but have less mass than the sun. Question 5, how can a star that has more mass than our sun be smaller than our sun? It could be more dense. It could be more dense. Page 469. What causes the apparent motion of the stars? Circle the North Star on the picture. How do stars move in the sky? Highlight. Two kinds of motion are associated with stars. Continue highlighting. Apparent motion across the night sky. Continue highlighting. Actual motion through space. The apparent motion of a star is easy to see. Astronomers must use telescopes and spacecraft to see the actual motion of stars. Apparent motion of stars. From Earth, stars appear to move across the night sky. Highlight. This apparent motion of stars results from the movement of Earth. Continue highlighting. As Earth rotates, stars seem to move in a circle around a central star. Continue highlighting. This central star is called Polaris, or the North Star. Polaris does not seem to move much because it is directly over the North Pole. Highlight. Earth's revolution around the Sun also causes apparent motion. Continue highlighting. As Earth orbits the Sun, different stars become visible during different seasons. The visible stars seem to move slightly to the west each night. After many months, some stars disappear below the western horizon. Question 6. What causes the apparent motion of stars? Answer. Movements of Earth. Movements of Earth. Circumpolar stars. Highlight. Some stars are always visible in the night sky. These stars never pass below the horizon. Highlight. These stars are called circumpolar stars. The stars in the Little Dipper are circumpolar for most people in the northern hemisphere. Highlight. At the North Pole, all stars are visible. All visible stars are circumpolar. As you move away from the North Pole toward the equator, you can see fewer circumpolar stars. Under the diagram, stars appear as curved trails in this long exposure photograph. These trails result from Earth's rotation. Question 7, circle the North Star on the picture. Use your highlighter to circle the point at the center of the circles. Again, use your highlighter to circle the point at the center of the circles. Page 470. Suppose distant galaxies had blue-shifted spectra instead of red-shifted spectra. What could astronomers conclude about the motions of these galaxies? How many kilometers are in 1 light year? Actual motion of stars. Highlight. Most stars have several types of actual motion. First, highlight. They move through the universe. This motion is not related to Earth's rotation or revolution. Second, highlight. They may revolve around another star. Third, highlight. They either move away from or toward our solar system. Continue highlighting. Astronomers study a star spectrum to learn about the star's motion toward or away from the Earth. Continue highlighting. As a star moves, its spectrum seems to shift or change. Continue highlighting. This shift in the spectrum is called the Doppler effect. Continue highlighting. The Doppler effect happens when an observer and a light source move toward or away from each other. Continue highlighting. For example, light from stars moving toward Earth shifts toward blue. Continue highlighting. This is called blue shift. The wavelengths of light appear to be shorter as the star moves toward Earth. Highlight. Light from stars moving away from Earth shifts towards red. Continue highlighting. This shift is called redshift. The wavelengths of light appear to be longer. Under the diagram, highlight distant galaxies have red-shifted spectra. Continue highlighting. This redshift shows that the galaxies are moving away from Earth. Question 8. Suppose distant galaxies had blue-shifted spectra instead of red-shifted spectra. What could astronomers conclude about the motions of these galaxies? That the galaxies were moving toward Earth. That the galaxies were moving toward Earth. How do astronomers describe distances? Objects in space are very far apart. For this reason, astronomers describe distances in space using light years. Highlight. A light year is the distance that light travels in 1 year. Continue highlighting. Light travels about 9.46 trillion kilometers in 1 year. Light from stars takes time to reach Earth. As a result, highlight, we see light that left stars sometime in the past. Continue highlighting. For instance, the light from the sun takes about 8 minutes to reach Earth. Continue highlighting. The light leaves the sun 8 minutes before we see it. Polaris is about 430 light years from Earth. Therefore, highlight, when you look at Polaris, you see the star the way it was 430 years ago. Question 9. How many kilometers are in 1 light year? Answer, 9.46 trillion. 9.46 trillion. Page 471. Which star would show a larger parallax shift? One that is 4 light years from Earth or one that is 6 light years from Earth? What two factors does apparent magnitude depend on? Parallax. Highlight. Scientists can use parallax to determine the distance to stars that are relatively close to Earth. Continue highlighting. Parallax is the apparent shift in a star's position when it is viewed from different places. Observers can study stars from different places as Earth orbits the sun. Highlight. As Earth orbits a nearby star will appear to move compared to stars that are farther from the Earth. Continue highlighting. The closer the star is to Earth, the larger the shift will be. Under the diagram, astronomers can also measure parallax from spacecraft. They have measured the distance to about 1 million stars within 1,000 light years of Earth. Question 10. Which star would show a larger parallax shift? One that is 4 light years from Earth or one that is 6 light years from Earth? Answer, 4 light years. How do astronomers describe brightness? Highlight. About 6,000 stars are visible from Earth without a telescope. Continue highlighting. With a telescope, about 3 billion stars are visible. Continue highlighting. Billions more stars are visible from telescopes that orbit Earth, such as Hubble Space Telescope. The visibility of a star, highlight, depends on brightness and, highlight, distance from Earth. Astronomers use 2 scales to describe the brightness of a star. Highlight. The brightness of a star as seen from Earth is called the star's apparent magnitude. Continue highlighting. The apparent magnitude of a star depends on how much light the star emits. It also, highlight, depends on how far the star is from Earth. Continue highlighting. The brighter a star appears from Earth, the lower the number of its apparent magnitude. Astronomers also measure the true brightness or absolute magnitude of stars. Continue highlighting. The absolute magnitude is how bright a star would appear if all stars were the same distance from Earth. Continue highlighting. The brighter a star is, the lower the number of its absolute magnitude. Question 11. What two factors does apparent magnitude depend on? Answer. How much light is emitted? How much light is emitted? And how far the star is from Earth. And how far the star is from Earth. Again, how much light is emitted and how far the star is from Earth. Page 472. Star A and star B are the same distance from Earth. Star A's apparent magnitude is 10. Star B's apparent magnitude is 15. Which star has the larger absolute magnitude? Explain your answer. How do scientists determine the temperature of a star? Give one example to support your answer. Why do stars appear in different parts of the sky during different months? What is a circumpolar star? How could you tell by observation whether a star is circumpolar? The closest star to Earth, apart from the Sun, is Proxima Centauri. Proxima Centauri is about 4.2 light years from Earth. How long does it take light from our Sun to reach Proxima Centauri? About how many kilometers is Proxima Centauri from Earth? Question 1. Answer can be found on page 471. Star B would have a larger absolute magnitude. Star B would have a larger absolute magnitude. It would be less bright. It would be less bright because its apparent magnitude is less bright from the same distance. Is less bright from the same distance. Again, star B would have the larger absolute magnitude. It would be less bright because its apparent magnitude is less bright from the same distance. Again, do remember that larger numbers mean something that is less bright. Question 2, answer can be found on page 468. They use the color of a star. They use the color of a star. The example that I used, Rigel, R-I-G-E-L, Rigel, is 10 to 30,000 degrees Celsius and is blue-white. Again, Rigel is 10 to 30,000 degrees Celsius and is blue-white. So the whole answer again, they use the color of a star. Rigel is 10 to 30,000 degrees Celsius and is blue-white. Question 3, answer can be found on page 469. Because Earth rotates and revolves. Again, because Earth rotates and revolves. Question 4, answer can be found on page 469. Stars that always appear visible in the night sky. Stars that always appear visible in the night sky. They make a curved trail around the North Star, they make a curved trail around the North Star and never dip below the horizon. And never dip below the horizon. Again, stars that always appear visible in the night sky, they make a curved trail around the North Star and never dip below the horizon. Question 5. Answer can be found on page 470. Take 4.2 years and multiply that by 9.46 trillion. And I would just write out the trillion. So 4.2 times 9.46. That problem, when you multiply it, gives you 39.723 trillion kilometers. 39.723 trillion kilometers. Just for your information, that would be 24 trillion 634 billion miles. Again, 24 trillion 634 billion miles to the next closest star.